7-10 roots and zeros on page 458 is pretty complicated, and so if you can get the basic ideas, that would be good, and then using the answer choices that they give you would probably be your best bet. Just plug the solutions into the equation to see which ones work. Now you're going to have imaginary solutions also, which is anything that has an I with it. That's an imaginary solution. So it's not a real solution. Real solutions are just numbers. So all of the solutions that we've had so far have been real solutions. But now they're going to introduce imaginary solutions. And they kind of just throw it into the section. They don't really talk about it a lot, which is kind of strange. So we'll talk about it a little bit, but not a lot also. And then I'm going to cut out some of the things because they're just too complicated to talk about in this chapter. Since you don't know any extra information, you have a lot of gaps that you cannot fill with this section. So I'm going to do my best and we'll see how it goes. Okay, so this first section says solve each equation, state the number and type of roots. So the number is how many roots you have, and then the type of roots are whether they're imaginary or real numbers or that type of thing. So on this one, we're going to solve it, and we're going to use our factoring methods here because your greatest common factor is x. So I'm going to factor out an x, and I end up with x squared plus 2 equals 0. So at this point, I'm going to set both of my factors equal to 0 and then solve. So x is one of my factors. If I put that equal to 0, then I already found one of my solutions. So this is one of the solutions, and then x squared plus 2 equals 0, and I solve minus 2 x squared equals negative 2. Okay, at this point, when I take the square root, because I want to get rid of the x squared part, the squared, so I would have to take the square root. But you cannot take the square root of a negative number. If you put the square root of negative 2 into the calculator, it's going to say error, because this is not a real solution. This is going to be called an imaginary solution. So if you'll... Basically, what you need to know about imaginary solutions are anytime you have a negative square root. So negative 1, let's say the square root of negative 1. This is I. So the square root of negative 1 is I. That means I can separate this into the square root of 2 times the square root of negative 1. Okay, the square root of 2 is going to be a decimal, so I'm going to leave that the square root of 2, but I'm going to change the square root of 1 or negative 1 to an I. Okay, so my solution then would be I, the square root of 2. And in this section, it talks about how if you have one imaginary solution, the conjugate would also be the solution. So this is one of the solutions, and the negative I square root of 2 would be the other imaginary solution. So we have 3 solutions, 1, 2, 3 solutions. 2 of them are imaginary and 1 of them is real. So I would say 1 real, 2 imaginary. Because it wants to know what the solutions are. So your solutions are 0, negative I squared root of 2, and positive I squared root of 2. 1 of them is real, 2 are imaginary. And so then you would be finished with this problem. The number for the degree of the polynomial, so this one is a 3 exponent, that's the biggest exponent. That means this polynomial is degree 3. So I should be looking for 3 solutions. And I have 3 solutions total. So on the next one, 4 is the degree of the polynomial. So this equation should have 4 solutions. And if I don't have 4 solutions, which can be real or imaginary, then I know that I am not finished or I did something wrong. So here again, I'm going to take the I'm going to factor this. So this is x squared minus 4, because this is a difference of squares. X to the 4th is a perfect square, and so is 16. So I would get x squared minus 4, x squared plus 4. And then this is also a difference of squares. So I would get x plus 2, x minus 2, and then I still have x squared plus 4. Okay, so I'm going to set every one of my solutions equal to 0, or I'm sorry, factors. So I have x plus 2 equals 0, x minus 2 equals 0, and x squared plus 4 equals 0. And then I'm going to solve each of them to find the solution. So minus 2, I get x equals negative 2. This is one of my solutions. Plus 2, x equals positive 2 is another one of my solutions. So I have two real solutions so far. I'm going to subtract 4. X squared equals negative 4. And when I take the square root, here again, I'm going to separate this into the square root of 4 and the square root of negative 1. So the square root of 4 is 2, and the square root of negative 1 is I. So I have x equals 2i, and x equals negative 2i. Okay, so I have 4 solutions, 1, 2, 3, 4, and 2 of them are real, 2 real, 2 imaginary. Okay. Number 3 is, there's no way for me to explain to you how this can be solved. So I would say, let's say your answer choices are negative 5, negative 1, 2. Negative 1, square root of 2, let's go I square root of 2, and I negative I square root of 2. 3, I square root of 5, and 10. And then D, negative 1, 2, 5. Okay, so first, if you are trying to do a multiple choice problem with solutions, we know that there has to be 3 solutions. So if there are any answer choices that don't have 3 solutions, you can cross those out. So let's say that this one also has 12. So if that one also has 12, we know that this is not the right answer because it has 4 solutions instead of just 3. Then we have numbers here. So if I put the numbers in for x and see if they equal 0, then I can find my correct answers. So if I have negative 5, I would have negative 5 cubed plus 4 times negative 5 squared minus 7 times negative 5 minus 10. And I would put all of this into the calculator. So if I do negative 5 cubed, I'm going to get negative 125. Negative 5 squared is 25 times 4 is 100. Negative 7 times negative 5 is a positive 35. And then minus the 10. So if I do negative 125 plus 100, I get negative 25. Plus 35, I get 10. Minus 10, I get 0. So 0 does equal 0. So negative 5 is a solution. So that means since this one doesn't have negative 5 in it, it's not the right answer. And this one doesn't have negative 5 in it, so it's also not the right answer. So I would pick the one that has negative 5. If there's more than one with negative 5, then I would do negative 1 next and see if that one is a solution. And I would keep going until I figure out the one that has the correct solutions. Okay, so this one has 3 real solutions. 3 real. Because I know I have 3, and this one has all real solutions. So 3 real solutions. And then on this one's a little bit easier than the last one. Remember how if it has 4 terms, we look for if you can factor it easily. This one did not factor, so we couldn't do anything with that. We just had to use the answer choices. But this one factors. So I'm going to split it in half and find the greatest common factor here. So the greatest common factor here is x squared. When I divide, I get 3x minus 1. And then my greatest common factor here is 3. And I get 3x minus 1. So my two factors are x squared plus 3 and 3x minus 1. Remember the inside of the parentheses, if it comes out to be the same, then that's one of the factors. And then the other one is the x squared plus 3. And we're going to set it equal to 0 and solve each equation. So x squared plus 3 equals 0 and 3x minus 1 equals 0. Remember, I'm looking for 3 solutions. So I'm going to subtract 3 and take the square root. Separate the square root of 3 times the square root of negative 1. So this is x equals I the square root of 3 and negative I the square root of 3. And the other one, I add 1 and divide by 3. So 1/3 is my other solution. So here are my 3 solutions. And I have one real and 2 imaginary. Okay. This next section is pretty complicated. It says state the possible number of positive real zeros, negative real zeros, and imaginary zeros. So here's how we're going to do this one. We take the original 2x to the 5th plus x to the 4th plus 3x cubed minus 4x squared minus x plus 9. And we count the number of, the first thing we do to find the positive real zeros, we count the number of sign changes. So this one goes from a positive to a positive, so that's not a sign change. This one goes from a positive to a positive, so that's not a sign change. This one goes from positive to negative though, so this one has a sign change from positive 3 to negative 4. Negative 4 and negative 1 is no sign change. Negative to positive is a sign change. So the possible number of positive real zeros is either 1, 2, 2 positive real zeros, or you can have 0. So it's going to be the number of sign changes or minus 2, minus 2, minus 2. You can have a factor of 2. So you can either have on this problem 2 or 0 positive real zeros. Okay, to find the negative real zeros, we would take the negative of the x's. So for example, this one is x to the 5th power. So if I were to put a positive 1 here, it would stay positive because to the 5th power would be 1 times 1 times 1 times 1 times 1, 5 times, which would give me a positive still. But if I change it to a negative 1, negative 1 times negative 1 times negative 1 times negative 1 times negative 1 would give me a negative 1. So if it's an odd exponent, that term will change to negative. So this is a negative 2x to the 5th. But if it's a even exponent, this one will not change because a negative 1 to the 4th power would still be positive 1. Okay, so then we have plus x to the 4th, no signs changed there. Then this is to the 3rd power, so this one would change. This one is squared, and so it would not change. This one is negative x, so this one would change. And this one would not change. Okay, so now we have to do the same thing we did here, but count the number of sign changes for this one. So this is a sign change from negative to positive. Positive to negative is a sign change. Negative to negative is not a sign change. negative to positive is a sign change, and this one is not a sign change. So possible number of negative real zeros. There's 1, 2, 3. So you can have 3 negative real zeros or 1, because again, I'm going to subtract 2 negative real zeros. So I can have 3 negative real zeros or maybe 1 negative real zero. Okay, so then we would just have to figure out the combinations. So if I have 2 positive real zeros, since I have 5 total, I could have 2 positive real zeros and 3 negative real zeros. That would give me 5 total. Or I could have 2 positive real zeros and 1 negative real zero. And then that would mean that I would have to have 2 imaginary zeros. So my options are, this is where it gets complicated. 2 positive real, 3 negative real, and that would be it. Or I could have 2 positive real, 1 negative real, and then 2 imaginary. So I have to have 5 total. 2 plus 3 is 5. 2 plus 1 plus 2 is 5. Or I could have 0 real positive ones, 0 positive real, and 3 negative real, which would mean I need 2 imaginary. Or I could have 0 positive real, 1 negative real, and that would leave me with 4 imaginary. So these are the possibilities for the number of positive, negative, and imaginary real and imaginary. Okay, so pretty complicated, but this is that type. Okay, this one says find all of the zeros. I think your best bet on this type is to just use the answer choices and plug them in. We know that we have to have 3, and so just use your answer choices. You can try to factor if you think you can factor. I mean, this one probably actually will factor. If we take an x squared, we get x plus 2, and over here we would take a 9 and get x plus 2. So our factors are x squared plus 9 and x plus 2. So I have x squared plus 9 equals 0, x plus 2 equals 0. Square root of 9, square root of -1. So my solutions here are 3i, -3i, and -2. So -2 is a solution, -3i, and +3i. These are my 3 solutions. Like I said, I'm looking for 3 solutions. But if they give you this answer choice, you can take the -2 and plug it in for x to see if that's one of the solutions. Okay, lastly, this one is even more complicated than the others. Write a polynomial function of least degree with integral coefficients having zeros that include -1 and 1 plus 2i. Okay, so because you have your 2 factors, you know that x plus 2, so the opposites, has to be one of the factors, because when we solve x plus 2 equals, plus 1, x plus 1 equals 0, we would get -1. And then the other one is going to be x minus 1 plus 2i, and x Okay, because these are conjugates, we know that these are your two factors. This one is a positive, so the negative one has to be a solution also. So I take the 2, and I know that x minus that would be a solution. So here's my polynomial. Then they take this part and they switch it around. So this would be 1 plus 2i oh, I'm sorry. They don't switch it around. They take the x minus 1. X minus 1 plus 2i. And then the other one is x minus 1 minus 2i. Okay. Equals 0. And then you still have the x plus 1. Okay, so then they say that this is the product of difference of squares. So when we change it up, we're going to have x minus 1 squared minus 2i times 2i is 4i squared. And then we're going to change the I squared to a -1, because if the square root of -1 equals I, then I squared equals -1. So when I factor this, or I'm sorry, multiply it out, I'm going to get x squared minus 2x plus 1. And then -4 times -1 is a positive 4. Actually, we don't need this, equals 0. Okay, I'm going to add the 4 and the 1 to get 5. And then I'm going to multiply x plus 1 and x squared plus minus 2x plus 5. So x times x squared is x cubed. X times -2x is -2x squared. X times 5 is positive 5x. 1 times x squared is x squared. 1 times -2x is -2x, and 1 times 5 is 5. Combining my like terms, I would get x cubed minus x squared plus 3x plus 5. And so this would be the polynomial with these solutions. So it's pretty difficult and it takes a while. So I would say if it's like this, you might just want to skip it. But hopefully that will help, and best of luck.